Welcome to the lecture series on object-oriented analysis and design. We are looking at the four major building blocks: polymorphism, encapsulation, abstraction, inheritance. So, what we are now focusing on is the fact that there are 5 different varieties of inheritance. Good examples are here. Single inheritance is what we are talking about. All students are the same. Only few students get a scholarship, not all get a scholarship. Well, there are cases where we can always argue. Generally, by and large, for example, at PhD level, both my students are getting scholarship. So, the point is, student is very generic, student having scholarship only few, all other attributes and methods remaining the same, only one attribute called scholarship is different. Multiple tiers, I gave an example in the last lecture. Hybrid inheritance, student, 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 and they can have one more inheritance round of another student, taking that there are certain parameters which this student belongs to one class, the other student belongs to other class. Put together, there is some interdisciplinarity kind of a thing, they will have one more student definable. Animal, mammal, human, multi-level inheritance, gradually it progresses. This is very easy to understand. Animal, mammal to human. Hierarchical inheritance, vehicle, land vehicle, water vehicle, air vehicle, land vehicle, car, bus, ship, boat, aeroplane. Then we have one more level. How do we make a hybrid land and water vehicle? This is an example which we have seen in one of our earlier lectures. So, in summary, we have this many types, a handful of types of inheritance. Now, what is the story here? Inheritance is a property by which the objects of a derived class possess copies of the data members and the member functions of the base class. A class that inherits or derives attributes from another class is called derived class. The class from which attributes are derived are called base class. So, this is the base class based on which most of the things will follow through except what we have defined. In the process, I can hide some attributes of the base class, I can take only the selected attributes of the base class. If necessary, I will go back to the base class. It all depends on the richness of the language which you are using and what kind of inheritance, what kind of flexibility the language expressions can support. In theory, object-oriented analysis is all this. It can support everything. As we progress in this lecture, we will understand what the languages are doing. In object-oriented programming, the base class is actually a superclass and the derived class is a subclass. Most of the textbooks would want to use this terminology, superclass, subclass, rather than base class and derived class. It happens the archaic object-oriented analysis and design papers, research and everything do have the idea of base class, derived class, whereas as we progress towards the later part, superclass and subclass began to become the standard terminology. Once again, please understand that standards are necessary, otherwise we would go haywire very soon. The goal of putting together things happens in the manner where we have been describing, because there will be some standards. Gradually, the standards began to emerge. There was a good group, object management group, even now it is there. The object management group OMG brought together all the stakeholders who were very keen on object oriented programming, and therefore, we start using a terminology that is stemming from the works produced by object management group. We will talk about UML later, we will talk about Corba later, but all these things are largely because of a set of standards which have begun to be accepted for the last 20 years plus. The work was transparent, people were contributing. There are various relationships between objects of different classes in an object oriented environment. It is not enough to identify the objects and the inheritance, but how are these objects related? The associations, the aggregations, the generalizations become very, very important for us. Inheritance relationship, each class is allowed to inherit from one class, and each class can be inherited by unlimited number of classes. So, these are the possibilities which we have been talking about as one to one, one to many, the relationships amongst the classes, if they are falling in line with our sets and relationships which we learn in high school algebra, it is lot more easier to proceed. And OMT, object modeling technique, object identification is one, the modeling part is dependent on how we clearly specify the relationship, and it becomes nice. The object management technique by Rimbaud and all talked about associations that are so structured. The relationships, the associations, the aggregates, the generalizations become completely amenable to what we normally do in sets, relations, functions and mapping. So, therefore, we can do the combinations of objects and relationships in any manner very easily, because it is just a mathematical abstraction. In 2 minutes we know what is happening, which relationships are happening. So, one of the core pillars of unified modeling language is OMT, largely because it is a mathematical structure. We need that mathematical structure. The database model of identifying the objects is very confidently proposed, because there is a relational calculus, a mathematical model that will allow us to verify and validate. If that step is not possible, we are likely to go haywire. At every checkpointing we should be able to tell that it is a working solution because of this reason. We will improve, we will make it a formal solution, we will make it a correct solution, but by and large our methodologies are geared up, and with the number one villain requirements always at the top of the stack, we always end up telling that yes, working solution, yes, we will attest, others we will progress, next version will be better, we will have more formalism. Composition relationship, that is aggregation. OOP allows you to form an object which includes another object, car and engine, the aggregation, putting them together. Utilization relationship, class to make use of another class, a driver, student, normally is not part of the car, but car and driver, student and pencil, they are completely unrelated, but then we can create a friend function, we can get that attribute. Instantiation, now please understand that at the time of beginning to use the object, there must be some values in the attributes, there must be some way the methods work on the attributes. How will you specify that this object's starting values are this? How will we specify that? That is what we called instantiation. For so many years, the language designers, particularly the most well known language design called Ada, always created this instantiation bottleneck. That is, when so many objects are brought alive, each object has to get a different start. What is the case for that? There are so many flights in the hangar which are idling. When they are brought to the gate and they are operational, passengers are boarded, suddenly 50 flights take off. Each one is not the same flight anymore. In the hangar, the same model, same number of seats, everything is the same. Everything is easy to understand. There may be some gigabytes of data associated with that also is fine. But once 50 flights are there at the gate and they are ready to take off, each flight is different. Now, the scale is 400 gigabytes now, the instantiation is a bottleneck, because passenger data is there, so much of data is there. Now, please understand that there are plenty of data that gets collected with every flight, but then what we know is only what we want to know, what we need to know, and that too with special authorizations, special authentications. Please try to find out if so and so passenger is on the flight. How much ever you know the carrier, it will be very difficult to get yes or no answer without proper authentication, without finding out n number of reasons. So, there are so many things that are happening around the program, around the object oriented, very difficult to get that data. Is he or she on board so and so flight, did they catch the flight? It will be very difficult. However, at the same time, we are always capable of being on the ground and managing a few things. It is quite possible that there is a case study that I can talk about. The relationships are not so hard and fast. Say for example, there was one very elderly gentleman who was always needing a wheelchair, and he has to travel from Hyderabad back to Chennai. This was a flight that was there, and it was in Hyderabad. Everything was spick and span. We got all messages saying that he is very much checked in from our own people, not from the airliner, from our own people, and my mobile number is there and everything is fine. Now what has happened? The flight got delayed, and since the flight got delayed and the elderly gentleman was there, they have given him some snack to keep himself refreshed, keep himself enthused, and he was there almost boarding time, and they helped him out. The wheelchair was there, took him to the tarmac, and all of a sudden he realized that the boarding pass is missing. Now they don't know what to do, have a mind that without the boarding pass we can't board. Luck is ours that he was still on the tarmac and his mobile phone was on. He could contact me, and he said, this is what is happening, boarding pass was issued, everything was issued, can you please tell me. Now this is nothing to do with the airliner except the support system. If you strictly talk rules and regulations, maybe nothing was possible like this, we wouldn't know. So these are called utilization relationships. A good example of utilization relationship where we talk about some possibility, they are all documented, you know, every airport is under serious surveillance, many things get documented, who gave the wheelchair, where is it positioned, we don't know that so much of data. People tell me that for every carrier now it will be minimum 400 gigabytes of data that will get documented, that will get docketed, somewhere it will be stored for some time depending on the airliner and the rules, aviation rules, civil aviation rules and regulations, they have to stock. This lecture, for example, it has to be stocked for about some weeks in the bay, and after that some 6 months or so elsewhere before anything can happen. These are all part of broadcasting rules and regulations. I have good friends who have been directors of the EM Square RC, the facility where I am doing this lecture. They have their own rules. This is the procedure, this is how you have to follow. So now the point is, the relationships, if they are so fully mathematical, we have a problem, one on one, one to one, one to many relation, it becomes very inflexible. The dynamics are difficult to manage. So therefore we created a dynamic polymorphism called a virtual function. Please recall the earlier slides, there is something called a virtual function. Dynamically, if you need, you can create that virtual function and solve the problem for the present. So we need all that, that is also polymorphism, runtime polymorphism with a virtual function. So we have thus created a way in which we can resolve to solve the earlier problem. We could sit down together and guess that probably when the snack was given, they took the boarding pass, some confusion would have happened at the time when the snack was given. We simply gave a clue and they solved the problem, he was on board and he came to Chennai. Simple problem, but very complex. The act is simple, and please note that if we are so task oriented, we solve the problem better. If we start thinking about the full data, putting one line in that, we will never be able to do. Nobody will be able to put a one line in that, the full input data, full output data. So these are some practical ideas where object oriented has been proving to be very useful. Very quickly we can get to the task, and we strongly think that abstract situation, whether you believe it or not, it has happened, that abstract situation is nicely modeled, and then we can replicate it for such abstract situations later. But then the point is, we need to understand that this is most likely the way we solve the problems very quickly, objects, things, the way we work. The simple hierarchy of mammals, we have discussed that. Using abstract class, C# enables you to create abstract classes that are used to provide partial class implementation of an interface. You can complete implementation by using derived classes. Most of the derived classes will have the same interface. It was a good idea we have been talking about. Most fans will have the switches similar interface, at least the way in which the power is on and the way we have to switch, you can easily make out. The specific differences among here I am seeing two fans, both of them are completely different manufacturers, but I know that this is the 0, 1, 2, 3 very quickly by identifying one abstract class. It does not belong to any fan here. No fan is subscribing to this way of thinking about an interface, but by and large please look for a switch that tells 0, a switch speed 1, speed 2, speed 3. You can always argue that in some fans speed 3 is the lowest, it is not the highest, but then by and large yes, look for these switches. That is a common sense argument which is a common base. C# provides you for that, other languages do not. Cannot create an instance of an abstract class, cannot declare an abstract method outside an abstract class, cannot be declared sealed. So, the abstract classes operate on different rules in this method which is supported by C#. Abstract methods are the methods without any body. The implementation of an abstract method, this is the basis of a virtual function also, is done by the derived class. It just tells please do this, how it is being done, it is up to that particular object, up to that particular individual, it can be anything, any object, if it is possible please do that. So, the abstract functions are always like that. Next idea, outside of associations and aggregations, the next idea to work with is what is called generalization. In the generalization process, the common characteristics of classes are combined to form a class in a higher level of hierarchy. That is, subclasses are combined to form a generalized superclass. It represents is a kind of relationship. For example, car is a kind of land vehicle, or ship is a kind of water vehicle. This is essential in abstraction. In the beginning there was nothing, from which came sun, moon, stars, air, water, fire, from which we got something else, chemicals came, substances came. So, what we are facilitating is that kind of a beginning, the Big Bang. Nothing was there, only the Big Bang happened. So, this is how we have been talking about all along, and when we started talking about this, car is a kind of a land vehicle, ship is a kind of a water vehicle, we think that we can address bigger problem. This is a package called mathematical functions library. Everything under the sun that you want to do in mathematical functions or computational mathematics or what is called scientific computing or numerical methods. These are 4 topics, everything is already there. Gradually we put them all together, made it the top. This is what is called a package of library functions related to mathematics, scientific computing, numerical methods, mathematical functions, all those things are covered. So, sine inverse is a kind of a mathematical function, please locate it there, it becomes so easy. What is sine inverse? It is just a mathematical function, then please connect all those things, link up to that package, it will locate for you what exactly to do. Specialization is a reverse process of generalization. Here the distinguishing features of groups or objects are the identity. So, at one end most of the time we are pushing towards the top end, so that we get a better grip on complexity, we can start addressing the higher order ends and therefore, we build better systems. At the other end, maybe this is a faster way of locating that slide, the very first slide. So, we like to get to this end at the earliest, encapsulates the feature of object oriented. Once I am here, I find that it is very easily manageable, higher order complexity, easy to talk. This is generalization end, this is specification, specialization. This will give you the identity. This is good for analysis of complex systems. This is good for building complex systems. The sooner you identify the objects or at least the classes, the faster you can do that, and all this happens at design phase, object oriented analysis and design. Everything is done and everything is easily managed. So, we go back to this slide again, the specialization slide. Look at it from the current slide here. The distinguishing features of groups of objects are used to form specialized classes from existing classes. It can be said that subclass are specialized versions of the superclass, or you can create some necessary specialization classes. For the particular context, I need to put together a few things. Temporarily, we need to get together a few things and then manage the entire exercise. So, generalization will take you up and up vehicles. So, my first question would be, how many vehicles are we managing? Then of that, how many are land, how many are water, how many are air. Specification, what exact type. So, we talk about traffic analysis. There used to be a nice time slot near our university early in the morning, where people who are helping to do the government to do the traffic analysis are given a nice camera, and then one way of taking stock of it, camera is installed early in the morning, time slots were all given. At this time, what is the traffic, next time what is the traffic, next time what is the traffic, how many, by and large how many vehicles, of which how many cars, how many buses, ship, boat, aeroplane, helicopter do not go there, cycles, how many people are pedestrians. So, what is the traffic that goes on that road? So, initially it is vehicles, then car, bus, scooter, motorcycle, cycle, bicycle, it is like that, autos, mini buses, heavy vehicles. So, we start looking at all those things. Some time slot will get heavy vehicles. So, you see how nice it is to talk about this first, easy to explain. What is the task? Please fix a camera at so and so place, these are the time intervals, keep observing how many vehicles are crossing the camera eye. That's all is to be done. It is recorded, they will make an analysis, next day is a different day. Over a span of some n number of days, it will stabilize, because large number of vehicles will go, statistically we will get a normal. This many, the normal traffic here is this many cars, this many buses. It's how, that's how the mathematics of traffic analysis begins. We have done it at the toll gate for some time. What is the way, how many cars, how many buses will happen. Toll plaza modeling itself has been a big exercise, very challenging exercise. Even today it is, mathematically it is so challenging, but all this need not be told to the fellow who is actually at the toll gate purchasing only the ticket, one way ticket or two way ticket, that is all. This is the amount he deposits, this is the change he gets, he or she gets. So, the fellow who is driving on this road need not be bothered about all this analysis. The vehicle that he has chosen, he or she has chosen, is going safely on the road without any hindrance, reasonable amount of time. That is the advantage of generalization and specification. So, therefore, out of all these, when we start working with the languages, there are different types of object oriented languages. Some are pure languages, languages that not only support, but also enforce all object oriented concepts are called pure OO languages. In these languages, everything from character and punctuations to modules is treated as an object. Smalltalk, the very first in its variety, lot of documentation is there about Smalltalk, and we learn language design. One of the languages that makes us learn what are the nuances of designing a language is Smalltalk. The other two, PL1 and Ada. Smalltalk figures very prominently in the way we have learnt how to design languages. Eiffel, done by Bertrand Meyer, he is an award winning designer of a language. Eiffel is a language, and what he taught us was object oriented construction, that is, how to begin that construction from bottom up. It was a very difficult exercise. It is easy to tell that you identify objects and you put them together. Until Eiffel was designed, we were not able to identify those objects which have an identity, and when put together will solve a problem. The language will force us to look up for these things. Ruby is a more modern language, are examples of pure OO languages. Hybrid languages, languages that support some, not all of the OO concepts are called hybrid languages. Java, Python and C# are the examples of hybrid languages. The consistency of a language is very, very important. Completeness of a language, it should fit very nicely in the way the context free grammar flows. The consistency, the completeness make us make some engineering compromises on what we will throw out. The full battery of object oriented concepts are found in pure languages. We make some engineering compromises, design languages like Java, Python and C#. Multi paradigm languages, languages that support many programming paradigms such as procedural programming, generic programming, one of which is object oriented programming is called multi-paradigm languages C++. You can do many things in C++, including what you have been doing earlier. It subscribes to multiple paradigms, but please remember, in the beginning of this, in these lectures I have indicated that mixed language programming, mixed paradigm programming was considered an indiscipline for so many years, so many decades. The business constraints like packages, not redoing the wheel, have allowed this mixed language programming irrespective of the language. When will it happen? After OOAD happens. So, OOAD is a very generalized idea. If you do that, you can start talking about coding, you can start talking about everything. Object based language, Ada is an object based language, whether we like it or not. Ada does not support multiple inheritance, whereas multiple inheritance is something which we need to understand very carefully. So, languages that support the concept of abstract data types, data encapsulation, data hiding, we talk about all these nice ideas which are called object based. The three top, polymorphism, data encapsulation and inheritance, are paramount importance. How much flexibility you have on these three depends on the other language classifications. If we start dropping any of these dominant features, we will start talking about object based languages. A comparison of some popular OO languages. What are the concepts? What are the most dominant concepts? Encapsulation, data hiding, inheritance, multiplexing inheritance, function overloading, operator overloading, dynamic hiding, class varieties and functions, pointer arithmetic, built-in data types are objects, user defined data types are objects, all operations are performed using message passing technique. There is no reason to think that these are the only object oriented concepts, but then they are useful. Most common object oriented concepts that allow us to compare how many languages. Effect is the name of an object oriented language. Smalltalk, Ruby, Java, C#, C++, Python. Sorry, there is a typo here, but this is an exercise that we have been doing over and over again, and we found that one language which has all yeses. Can you find one language in this table? Very difficult. Every language has made some engineering compromises, engineering choices. So, we think that the core concepts are there very nicely in C++, most of the concepts, so that it can straddle across multiple paradigms. The top 5, the top 6, how many languages score yes? Only one language scores yes on all that. It is C++. C# does not have multiplexing inheritance. So, what we have done is, this is the way we work with object oriented, because object oriented analysis and design is one, but then we have to carry forward. We can't halt at OOAD. We begin working with it by choosing an object oriented language based on its features. Multiple languages, these are not exhaustive set of languages, only 7 languages are here. There are so many other languages which are happening, which will happen. So, we should know how to compare the languages to work with object oriented. Thank you. We will meet again in the next lecture.